Learning target 3.10 says I can convert between grams and moles. So let's look at two different examples here. Example 1 says determine the number of moles of CO2 or carbon dioxide in 454 grams. Now the first best step in all of your stoichiometry problems is to identify your known value, which in this case is 454 grams, and also identify what you're trying to find, the number of moles. So in this case, we know we are starting with grams, and we are trying to find moles. Now, the first thing you want to do in every single problem is write down your known value, which in this case is 454 grams. Next, you want to set up your T-chart. Now, in order for our units to match, you know that you're going to have grams in the denominator. And you also want to find moles. The question is asking us to find moles. So you want to have mole on top. Now, we're solving for moles of CO2. And if we have 1 mole of CO2, we need to put the molar mass for carbon dioxide in the denominator. So, if we look on the periodic table, we see that the molar mass for carbon is 12, and the molar mass for oxygen is 16. But we do have 2 oxygen atoms in this molecule of carbon dioxide. So we have 2 plus 6 is 8, plus 6 is 14, and 1 plus 1 plus 1 plus 1 is 4. So the molar mass in this case for carbon dioxide is 44 grams. So now we need to multiply across. And this is going to work out great. If we look closely, the units grams and grams are going to cancel, and we're just going to be left with moles. So now since you're multiplying 454 times 1 over 44, it's the same thing as dividing. And if you divide 454 by 44, you would get 10.3 moles. In the second example, we're going to be converting from moles to grams, but the process is very similar. So we want to identify our known value, which in this case is 0.75 moles, and we also want to identify our unknown value, which is grams. So we start with our known value, which is 0.75 moles, and then we're going to multiply by our molar mass. So if we have 1 mole of KMnO4, we need to figure out how many grams there are in 1 mole. So down here I'm going to show us the work for the molar mass. But the molar mass for potassium, or K, is about 39. The molar mass for manganese, or Mn, is about 55. And then the molar mass of oxygen is 16, but we know we have 4. And 16 times 4 would give us 64. So if we add those together, we take 39 plus 55 plus 64. That would give us a total of 158 grams. So now our units of moles are going to cancel, and we're just going to multiply across. We're going to take 0.75 times 158. And if you take 0.75 times 158, that gives us 118.5 grams. So why don't we try these two different individual examples? Number one, saying calculate how many moles there are in 17.0 grams of H2O2. And number two, saying if a scientist has 1.18 moles of hydrogen peroxide, or H2O2, what is the mass of the sample? And when you're done, resume watching the video to check your setup and work. So, in number one, we took 17.0 grams, which was our known value, and we wrote it in the upper left corner of the T-chart. And then we divided by our molar mass. So we knew that if we had 1 mole of H2O2, that would equal 34 grams. Then we reduced it over here to 17 over 34 after we crossed off our grams. And 17 over 34 is equal to 1 over 2, which as a decimal is the same thing as 0.5 moles. Number two, we also took our known value of 1.18 moles, and we put that in the upper left-hand corner. And we multiplied that this time, since we wanted to cancel our moles, by 34 grams, which again was the molar mass of H2O2, over 1 mole. And when our moles cancel, we were just left with 1.18 times 34g, which gave us a final answer of about 40 grams. Now, just make sure that you're thinking about being really careful with your math and simplifying. Again, you did all this beautiful work, you crossed off your units. You really don't want to just lose credit on that CST and get one question wrong just because of a little simplifying issue. So I'm talking about kind of like right up here. When we have that 17 over 34, make sure you do reduce that correctly, and not as 2 over 1, but a correct simplification of 1 over 2. So just make sure to be careful of that on the entire process of doing stoichiometry on the CST, and even when you go into the practice on the exit ticket next. So careful with your math and simplifying.